Lesson 46, page number 203. More on radical expressions and radicals to fractional exponents. All right, so Riley had a good point that he just expressed to me. Haven't we done these, or didn't we do these a long time ago? Yes. But the only way for you to learn is to take previous experience and build on it. So that's what we're doing.
I concur.
We are taking previous experience, ergo what I have on the board, and we're going to build on it in a minute. But first of all, what I'd like for you to do is share with me what in the world you do with that to simplify it.
So make it the square root of 2 and the square root of 3.
All right, so Riley suggests that, and then what?
Pretty much do the same thing on opposite.
Now notice what I did with the 3. Whenever you have a mixed number and you have a radical like that, you can take that mixed number and put it in the numerator position. You cannot put it in the denominator position unless it was 1 over 3. But in this case it was 3 over 1. We moved it into the numerator position up here with the 3. Okay, once we're at that point, what do we do?
Times it by the denominator.
Multiply top and bottom by the radical. You don't necessarily multiply it by the whole denominator, in this case you do, but it's just times the radical. So 3 square root of 3 over square root of 2, square root of 2, square root of 2. And when we do that, what do we get here?
Square root of 6 over 3.
Good?
3 square root of 6 over 2.
Okay. At this point, what do we do?
Multiply it by the opposite denominator.
By the opposite denominator. We're trying to find, I know what you're saying, but what we're trying to do is find common denominators.
Please.
And she's doing it by multiplying this times 2 plus, and this is going to be a 6, so that means this has to become, whoops, a 9. A 9. And we get what?
11 square root of 6 over 6.
And what do we do with that?
Nothing.
Meeks. Nothing.
We.
We don't do anything with it. That's as simplified as we go. Okay, so if, what was that last?
I don't know how we got here.
Okay, well that's what I need you to tell me. All right, so where did I lose you?
No, it's just at the last.
So you're good down to
I
here?
just wasn't paying attention.
Okay. You okay? I mean, I don't want to go on if.
It's good.
All right, so this is what we have done. All right, so now we're going to add a little bit of a tweak to it. Now let's call it a big.
Big tweak.
Now it wouldn't be a tweak
Medial.
if it was big. What would it be called?
69.
That's
game.
It's a big
A baroom.
It's
A
a
baroom. Baroom. That's not big.
Oh.
Is that a tweak? A verumulus tweak. Wouldn't a tweak be small technically?
Yeah, that's what I was saying. It's
That's
more
why
than
we
a
need
tweak.
We're crying out.
Tweak is
So it's a
small
baroom.
and tweak is
Still
big.
recording.
Okay.
A tweak could be a wrench.
A wrench.
A wrench.
A pipe wrench.
Like
Yeah.
a wrench in your
We're gonna throw a pipe wrench. in
This
this
is don't
video.
mess with success. This is pushing success off the cliff.
Okay. So,
Now I'm scared.
what is the direction that we want to end up with here? I mean, what is our goal with this?
Get it and solve.
To get an answer. And Michael, what does our answer look like? It looks like stuff with no pluses or minuses in it. We want to try to combine everything as much as possible and have the most simplified answer. Sometimes there might be, but we try to get it as simple as possible, and what that means usually is to get it down to one term if possible. So, we're going to do the same thing we did in the last one. We're going to change this to 3 square root of 5 over the square root of 2. Any problems doing that? That's a normal occurrence that you should be doing regularly. Kind of like brushing your teeth.
Every morning and night you should turn.
Okay. Square root of 90. Can that be simplified?
Yeah.
Into what?
3 square root of 10.
30 and 3, right? And Seth, what did you say?
3 square root.
3 square root of
Seth said 3 square root of 10, which actually, before he got to that answer, which is correct, by the way, he had to find two numbers multiplied together that give him 90, that he can take the square root of one of them. So I use 30 and 3. Can't take square root of either one of those, so I throw that one out. He used 9 and 10. He can take the square root of 9, so that's why he used that, and the square root of 9 is 3. And if you remember, if you take that simplified and you square the term that's outside the radical, multiply it by what's inside of the radical, you better get your 90 back. 3 times 3 is 9, times 10, you get your 90 back. So he knows he did it right. Okay, so at this point, what's my problem?
Not a fraction.
Okay, I don't have a fraction on my 3 square root of 10, but that's okay.
You don't have common denominators.
It's over.
I can put it over 1.
Thank you.
Okay, so I gotta get common denominators. Before I get common denominators, what do I need to do? Gotta get rid of my radicals on the bottom. So 3 square root of 5 times square root of 2 plus 3 square root of 2 times square root of 5 minus 3 square root of 10 over 1. All right, so kind of skipped a step there, but not really. I mean, I just took the square root signs off of here and multiplied the top by that. So I get 3 square root of 10 over 2 plus 3 square root of 10 over 5 minus 3 square root of 10 over 1.
Whoa.
Find common denominators.
10.
All right, my common denominators are 10. So I multiplied this times 5, so I multiplied the top by 5.
Wait, on this, can you do that thing where you do like the parentheses around the whole thing?
No,
You know what I'm talking
because you have an equal sign.
Oh, yeah.
All right, then this becomes a 10, guys. Minus, what do I do with this?
You have to multiply it by 10.
Okay, now when I combine terms, what has to be true in order for me to combine those 3 terms up there, Riley?
Common denominator.
Common denominator and,
Common number inside the.
yes, the number in the radical sign has to be the same as well. So, when I combine all of these, what do I get?
Negative 9 square root of 10 over 10.
Negative 19 square root of 10 over
Take away the
10.
1 in front of the 19.
Yeah.
It's not actually there. 21 minus 30.
Oh, that's a 15. I was looking at it as it being a 5. It's like, wait a minute.
Don't take that, students.
So what is it now?
Right.
Negative
9
9.
square root
Negative
of
9 square root of 10 over 10.
So I think you guys just do my math. You know?
Okay, let's move on to some fun stuff.
Yes. Fun stuff.
Fun stuff as far as fun for me, not for you.
We move on
Are
to
you up
lesson
at night
47.
thinking about ways to, torture us? or something?
I usually do it when I'm chopping wood.
Do you picture our heads as the block of wood?
No, usually fingers, that's more painful.
Oh,
You wouldn't
snap.
feel it if it was your head.
I don't know. You did
Oh, no, this doesn't look fun.
Now, I have heard, I don't know if it's true or not, but I have heard that back during the French
It's more than
Revolution,
one.
back in the guillotine days, that they would grab somebody. I mean, who came up with the invention of finding a sharp blade to cut some? I mean, that just.
that was
Some
better.
rock fell off
It
a
was
cliff and it just
better
cuts
It was
What?
better
It was probably
because
the headsman who usually cut people's heads off.
We should test.
Okay, so given something like that, guys, and this is really, really important,
Square root of square.
as you get into upper level math, you'll use numbers left in that radical sign less and less.
Yes.
You'll not get away from them completely because a lot of times they're just easy to work with, multiplying, dividing. I mean, they're really easy to work with. But there are other times where they're very difficult to work with. So what you end up doing is changing your radicals to exponents. And then you can follow these rules that you already know as far as exponents are concerned. Okay? So, the square root of 3 can be written with an exponent as what? 3 to the 1/2 power. Okay?
Dang.
So what we're going to do is we're going to change these things. So we're going to put
The other one's gonna
3
be 4.
square root of 3 in a 1/2 power. So all I did was replace this radical sign with a 1/2. Then I'm going to take my other 3 right here and I'm going to change it to 3 to the 1/2 power. Okay? So I got rid of my radical signs completely. Using our power rule, it says that when we have a radical outside here, it applies to each part of what we have here. So, 3 to what power? What power is this on the 3?
1/2.
A 1.
Oh, well.
Okay. If it doesn't, if there's no radical on there, or I'm sorry, if there's no exponent on there, it's an assumed 1. Okay? So, using the power rule, such as this, what does this mean?
2 power.
It means multiply. 2 times 3 does not mean add. All right, so what is the exponent on this 3 given this 1/2?
Half.
3 to the 1 times 1/2, which is 1/2. What is 3 to the 1/2 to the 1/2 power?
1/4.
1/4, because we multiply 1/2 times 1/2 and get 1/4. Slow me down
Slow down.
if you're having a hard time getting this quick on a Monday after 4.5 days or 5 days off. So it happens when you get new stuff. Sometimes it doesn't click.
Or when you've been
All right.
waiting for new stuff for forever.
All right. Am I done?
Yes.
Madison is done. She's gonna go watch TV.
Elias is done.
Elias is done. Adam, his attitude is, we're never done.
That's the answer.
No. Well, because Madison's done.
Whatever I say goes.
Whatever she says goes. Okay, so if for some reason we threw Madison's idea of being done out, Seth? Oh, I can.
Seth's done too.
So we have 3 to the 1/2 times 3 to the 1/4 when we're multiplying numbers with exponents. When we take two numbers and multiply them with exponents, what do you do with the exponent? What, Ben? Yes. Equals 3 to what power?
3/4.
3 to the 3/4 power.
9.
No. Nope. Okay, so if we have 3 to the 3/4 power, can you write that, what, Erica?
Oh, because you changed the one fraction.
Yes.
Where'd the other 3 go?
What other 3?
There was 3. It was assimilated 3 times 3.
So it's not 9 to the 3/4 power?
No, it's not. It's like saying x squared times x cubed is x to the 5th, right?
Oh, yeah, okay.
We're just adding the exponents. We didn't do anything here. If we have 2 x's, guys, 2 x's there and 3 x's here, we end up with
But
five
what
x's.
if you had like, say,
So
Three
these
X.
x's, we didn't go x squared to the fifth power. We just have 5 x's there.
what if you had a different number in one of them, like 3.5 times 4 and 1/4?
Oh, good question. 3 1/2 times 4 1/4, you're done.
Oh, okay.
Unless that bottom number is the same, you can't go any further.
Why wouldn't you just?
So pray for
Do it
different
on
numbers.
that one.
Pray for different numbers.
No, don't pray for different numbers.
Not pray for
Oh, are you sure?
Right.
All right. So, how can I write this in radical form?
The fourth root of 3 cubed, right?
Which is the fourth root of
27. Boom.
And that's your answer?
Well, I will take this answer. That's just fine and dandy, but the fourth root of 27 is actually an option as well. Okay, so let me give you one for you to play with.
It's really okay. That is it. I forgive you if you.
There you go.
Oh, yeah.
Hey, fine.
That's saying.
You just love us so I don't get this. You might want to pause it.
Yeah.
Okay, so first of all, we're going to take our index and turn it into an exponent. So 3 square root of 3 to the 1/3 power. Then we're going to go inside further. So we started with the outside, now we're going to go further inside and change our other radical. Okay, and you've got to remember that this 1/3 goes not only to the 3 to the 1/2 power, but also to the 3 that's in front of it. So we have 3 to the 1/3 power times 3 to the 1 over what? So we have 3 to the 1/3 plus 1/6. Common denominators in order to add those. So we end up with an answer of the square root of 3, or 3 to the 1/2 power. Okay. Can I?
You probably did say.
Okay, so there's another example for us to work on.
Push play. Oh, you are
You
playing.
did.
Oh.
As far
We're gonna edit
as
that out now.
as far as figuring this out, again, you work on the outside and go in. And obviously, we don't have any radicals within a radical. We just have the one radical. So, Rochelle, if you were to look at this first part right here, any ideas how we would rewrite that? Using an exponent instead of a radical. No. Okay. Kendra, you think you do?
No. XY 3 over 2 or 2 over 3? No.
X, Y, and 1/3.
Could have edited that out.
All right. Let's leave what's underneath the radical alone. All we're going to do is replace the radical with an exponent. So we're going to leave what we have in the radical alone, and instead of a radical sign, we're going to put an exponent of 1/2, because this has got an index of 2. It's an assumed 2 there. It's a square root. Same idea for this next one. We're going to leave the xy alone, and what's our exponent going to be? 1/3.
Half of 3.
Okay. Once you get to that point, it shouldn't be too wretched. Using the power rule, what do we get for my x value, or my x exponent?
Number 6.
Okay, I've got a 3 times 1/2.
So isn't it like 3 over 1 times 1?
Did that wrong.
3 over 1 times 1 over 2 is 3 over 2. 3 times 1/2 is
So
3
would
and a
y
half.
just be
Or
1?
Hmm?
It's 2 over 1 times 1 over 2 is
Good
1.
question.
Y is 2 times 1/2, which is 1, so we don't need anything else on that. All right, over here, it's really easy. We just put the 1/3 on each one of the each one of the parts.
No.
Nice. Okay, so we can only combine like terms, right?
Yeah.
We can only, these aren't not necessarily like terms, but we can only combine our x's with our x's. So x to the 3/2, multiply or add 1/3.
Add.
Y to the 1 plus 1/3. And this is what gets a lot of students in trouble. They take this, and because there's nothing over here, they just leave it 1/3. But there's really a
That is
y, a
wrong.
1 there. That would be wrong.
That's why I wrote my one.
So, what is that going to be? X to what power? We're going to have 9 over 6, right?
Yes,
Plus 2 over 6.
yes.
And then my y is going to be 3 over 3 plus 1 over 3. So I get x to the 11 over 6, y to the 4 over 3.
Then you're done.
Then you're done.
Really?
And that's how I want it left. Okay. Let me give you one for your enjoyment.
No.
That's like
No, please, you can have them.
X to the 5th,
You have them.
y cubed, and we will take the cube root of that, and then we'll take the 4th root of
X, Y to
x, y to the 5th. All right, so give that one a shot.